Hi friends. So we all know the hype around data science. So let's start with an introduction and history in computers and how data science has developed. So we'll be working around that. So when people ask me in a layman language what is AI, how AI works, I generally tell them that you can compare machines and computers. So when you come into the comparison part of it, so there are two parts. Basically, two three things which we have to note. For example, whatever we see from our eyes is equivalent to what computer sees from the camera. Whatever we speak out of our mouth is similarly to the speakers of the machine, how the computer is speaking with the help of a speaker. And when we try to listen something, it's like a mic where the computer tries to listen whatever we are speaking with the help of mic. Now, understand our brain is a processing unit, and in the brain, we see a picture and we are able to match it to see what it is, how it is, and what things are around it. So, our cameras, which is our eyes, we see things and we interpret with the help of our mind. Similarly, whatever we want to speak is another method where we are just producing sound with the help of mouth, but our brain is targeting how to speak the things. Similarly, mic listens noise or something which is not related to it, but brain interprets what it means, what things are coming from, and how the things are there. So our brain does all the processing units. Fun fact: camera part is image processing, speaker is natural language generations, and mic or the ears, whatever it is doing, is natural language processing parts where it is trying to do with the audio thing. So this is something which I generally tell to laymen. Let's shift to the definition of data science when it comes to the more formal side of it. It's data science is the art and science of turning raw data into insights. So we have data and we are basically taking out things out of it. It's like having a superpower that lets you predict the future, improve things around you, and make informed decisions based on the fact, not just guesses. So it can fall into different parts. Credit card companies are finding who can pay the credit bills or not. That's a basic application of it. We are trying to predict a lot based on the data. For example, a survey, you can understand in your area like what is the liking or disliking of a product. It may be a food thing, or depending on your area, how where you're living, what is the buying power. You can understand that what products people like and what products don't like. And the same thing goes in a lot of digital marketing things which are happening around us. So now here comes the boring part, the history lessons, how things are working in the world, where it started and everything. So before computers in 1801, Joseph Mary invented like a loom machine where it was kind of a mechanical computing. They used to have a punch cards to control the sequence and operations and weaving to design a pattern. So that was the first interaction where we were trying to make in the communication with the machine, and we were trying to give it a sequence and things were coming out. Then almost after 150 years in 1946, there was like first general purpose computer which was known as electronic numeric integrator and computer, ENIAC for short. That was a very huge one. You can see the picture over here. It was a very big computer which was there. So after 1946, another 50 years or odds were there, and then there were multiple notable works between 1801 to 1946 by Charles Babbage, Ada Lovelace, Alan Turing. And we'll know again, Alan Turing is one of the earlier pioneers for AI or data science, what we know right now. So these are the three people who worked a lot between the like for the 50 years between 1801 to 1946. Okay, then Turing test was the first thing where it was something which was related to us, which is data scientist or artificial intelligence, we were thinking on in 1950. Alan Turing published Computing Machinery and Intelligence, a research paper which was proposing a Turing test for evaluation of machine learning or machine intelligence. The main question he was asking was, can machines think? After 1950, in 1965, another 15 years, there was a conference, or maybe one of the first conferences, where multiple people gathered and gave the birth artificial intelligence as a field. So they were people who were doing researches at those times, and they were most of the mathematicians which were doing those things. After, again, in between, there was early neural network, which was given by Frank Rosblad, invents the perceptron, or like a very early neural network. It's a relatively image is given here, but not the exact one. Then next few decades were dedicated to data. I figured, and Julian like gave computers and thoughts analogy, which was a AI part. Then relational database came up from Edgar F. Codd. Then Oracle like released their first commercial SQL relation databases management systems. Then after another decade, they invented World Wide Web, and then there was data mining in 1990s. And there was like pattern recognitions on large data sets were also coming up. So here is early 2000s, before which we do not have a lot of in data science, but these are like the golden periods and very low periods, and whatever has happened in computers, you can see a lot of things which has happened in between. This is one of the graph where you can refer what is the golden age of science fictions. Then machine can think from Alan Turing came up. Then the first stored program computer languages was there in 1949, and logical theories came up in 1955. Then there was like artificial intelligence project on 1956 from Dermout. Then DRPA funds AI at MIT in 1963. So then there was Moore's law in 1965, and then things came up very quickly, and till 2000 there was nothing called data science as in and there, but in like after a few time we got the name data science. In 2001, data science word was made popular. Popularizing of data science was done by William S. Cleveland's paper Data Science, an action plan for expanding the technical areas of the field of statistics. Popularized the term data science, and he emphasized the expansion of the field beyond traditional statistics, incorporating data analysis, machine learning, and compoundal methods. Before this, most of the work which we call data science right now was part of more like statistics, and that was how things were doing. Now there are multiple things which are coming in data science. It's a combination of stats, maths, pattern recognitions, doing data mining, machine learning, AI, neural networks, visualizing them, and now extended to LLMs and these all things. So this is the classifications which you can look over the screen. Then in 2006, there came deep belief networks, DBNs, and that was a deep learning breakthrough by Jeffrey Hinton. He published a paper on the same, and at that moment, it came to back to life. Now the AI work which was being done in 1956, which was from Turing, there was a very big gap, but suddenly the data science picked up from 2006, and then in 2008 there was the Google file system which was working there. GFS were there, but in like the recent times, 2009, there was 1 million prize Netflix, which was Netflix prize, which was for a recommendation algorithm, and by over 10% they got their hands better on the recommendation systems, whatever there was for the Netflix. And this was done by Belco's Pragmatic Chaos team, and they won 1 million in 2009. 2010, whatever GFS was there, big data came up, and this was again a big data era. HFS systems and Hadoop, MapReduce, and multiple things came up. They were big data is basically based on four V's, which they call them very much fundamentals. That is volume, verity, veracity, and velocity. We'll discuss this somewhere around in another session. But in 2012, LXNet came up. This was for image processing, and it's a deep convolution network. So they win ImageNet large scale visualization recognition challenge, and this was something where GPUs were there, and training started becoming very popular. After that, in 2014, there was another breakthrough, which was generator adversarial networks, which is GANs. And GANs are basically generally used for generating and then detecting for it. For example, if you want to create some signboards for a project which is related to, say, self-driving car, and you want to have some signs which are not there very regularly, you can try to generate them, and then there will be a detector system which will be finding it's real or fake. So this all thing happened in 2014. Also, 2014, deep networks were also there. It's again, deep networks is something which is called for reinforcement learning. Now they have agents, and you can teach them anything they want to, like you want to train it on. You'll have cat and like you will have carrot and stick method, in which you will train the agent and in such a way that those agents are able to learn the things. It's like teaching a small child. They'll make mistakes in the starting, and they will eventually they grow up so much that they are able to make it very popular. We'll also learn about AlphaGo, which is also another part of reinforcement learning, but we'll go forward. So as I told you, AlphaGo in 2015, AlphaGo was one thing where they defeated European Go champion. It was done by DeepMind's AlphaGo, which is Google part. So they were able to beat a professional human person with the help of computers. Also, there was another architecture which is RASNet. It's one of the most used architectures in image processing. That also came up, and it beated a lot of image processing networks. So these was some of the histories from 2015. In 2016, AlphaGo was again getting popular, winning things, and they were mastering complex games with vast search spaces. Also, IBM did a lot in healthcare in 2016. They started doing things, and they were able to analyze a vast amount of medical data, and they were able to diagnose cancers and other diseases with the help of medical data. In 2017, transformer models came up. So now transformer models are having encoders and decoders. It's more of used in NLP and these kind of things. And even the BERT or LLM models have part of transformer models and some architectures which are there. So these things are having a lot of value in today's world. There was a paper which was attention to is all you need. So this model which is being used a lot right now. Also, during this time, you can understand that when even in image processing, there is transform models which is being used. They do not have decoder models; they have encoder models. We'll discuss that on later stages. In 2018, BERT came up, self-driving cars came up, and these things are very much there. BERT is a very advanced NLP thing which was developed by Google in a pre-trained transformer-based model, and these are doing a lot of capturing in things right now. So this is pre-LLM era. This was one thing which was very much there. Beyond did self-driving cars. They started in 2018, and Tesla now is very much ahead in self-driving cars. In 2019, GPT-2, so the LLM models, which was like there are multiple others, but I will be focusing that the GPT came up, and in this GPT-2 era, this was a LLM model which was doing a little of things whatever we are doing right now. It was a basic one, but it showed what potential it had. In 2020, GPT-3 came up, and there was a huge thing which was happening in 2020. That was one thing which was trained on 175 billion parameters, and the NLP world changed after that. AI in drug discovery, AI technologies has increased use in accelerating the discovery of drugs. And as you know, in 2019 we had a COVID. AI helped a lot in finding the drugs out. In 2021, OpenAI came up with Dali, Clippy, and they Codex was there, which was able to understand generate codes. GitHub Copilot is there, which is helping us to code better, and a lot of things came up. So they got into multimodal AI, they got into vision, large language understanding was there, large image models came up, and multiple things came up. In 2022, they got into art, where AI is writing literatures, composing musics, and gaining a lot of attentions. Now, after 2023, in 2020, also in 2023, LLMs and climate modeling came up. ChatGPT came up with GPT-4 now, and they are doing 4.0 mini also, and a lot of things. So AI is moving very fast right now, and in last 20-24 years, data science has changed like anything. AI in climate modeling is one of the things which came up. So they are trying to improve the climate models and predict environment changes and accurately get how the things are going to do. We were working. So I was working with geospatial data analytics, which is mental labs. So we started with giving 5 inches by 5 inches. What is the crop? How is the quality? We were able to get predict the environment, and then we were trying to say that what crop is going to give you the output and how things are going to come. So these are some of the models which were there, and 2024 a lot of things continue now. So we'll get a deep dive into data science. We'll be learning each and everything which is there, and then we'll be doing a lot of things. So welcome to the new series of data science. Let's meet.